Alright, so like I said, today we're looking at inverse relations in functions. And it says each number path will lead you from a number in the domain, the set of all real numbers, to a number in the range. It says start with x. And then we would subtract 3. So we start with x. So we say f of, well, first we're trying to figure out what f of x equals. We start with x. We subtract 3. We multiply by a negative 2. Hold on. We're going to erase that f of x right there. Alright, so we start with x, subtract 3, multiply by negative 2, and then add 5. Follow the number path to find f of 1. So we start with 1. So we would have, so f of 1 equals 1 minus 3, which is negative 2, right? What's negative 2 multiplied by negative 2? Positive 4. And then we add 5, so f of 1 should equal 9, right? So let me plug it in that equation that I came up with to see if my equation was correct. And yep, we did it right. So now, for g of x, we're going to start with x. It says square the value, and then subtract 2. Find g of 1. Start with x, or 1, add 1, so that's 2. Square the value, so 2 squared is 4, and then subtract 2 would be 2. So g of 1 should equal 2. Let's plug it into my equation. And it does. So now they want us to identify all possible values of x that lead to f of x equaling 7. So we came up with this equation. So now we got to let f of x equal 7. So we're going to say 7 equals negative 2 times x minus 3 plus 5, and we're going to solve for x. We're going to do the same for g, so let g of x equal 7. So 7 is going to equal x plus 1 squared minus 2. So let's figure out all possible values of x that lead to give us f of x equals 7. So first I need to subtract 5, don't I? So I have 2 is equal to negative 2 times x minus 3. What would be my next step? Can I add 3? No, because it's in parentheses, isn't it? How do I get rid of this? Well, we could distribute, or it's being multiplied, isn't it? So could we do the opposite of multiplication and divide it? So we subtracted 5. Now we're going to divide by negative 2. Negative 1 is equal to x minus 3. We add 3 to both sides, and we get 2 is equal to x. So f of 2 would give us an output of 7. All right, now let's try g of x. We're going to start by adding 2. 9 is equal to x plus 1 squared. So we take the square root to get rid of a squared, right? Square root of 9, though, could be positive 3, but it could also be negative 3. So 2 could equal x, or negative 4 could equal x. So that g of x has 2 possible values that would give us 7. So we're talking about inverses. And that's why they had us look at this number path. So it started with subtract 3, multiply by negative 2, add 5. But let's look right here. We started at the bottom and we did the opposite. Instead of adding 5, what did we do? Subtracted. Instead of multiplying by negative 2, we divided. Instead of subtracting 3, we added. So we did the same steps we did opposite steps in reverse order, right? Same for this one. We added 2, and then instead of squaring the value, we took the square root, and instead of adding 1, we subtracted it. All right, we're going to flip over to page 136. This says identify the inverse relation and is it a function? So I'm actually going to kind of pull up so that you can see where I'm getting this from. I'm going to pull up our textbook. They're seeing me go through all these steps. Let's see if this will show us. Nope, that's not what I wanted. Alright, so here for example 1, it says, what is the inverse relation in the table? It says, recall that a relation is any set of ordered pairs, x, y, where x is the independent variable and y is the dependent variable. An inverse relation is formed when the roles of the independent and the dependent variables are reversed. So this was our relation, negative 2, 1, negative 1, 4, 0, 3, and 1, 1. So they took the independent roles and they now became dependent. Y'all see that? And how the dependent roles now became independent. So they switched, right? And then they talk about whether or not it's a function. Remember, it's a function based on if it has, or if it does have the same x value twice, it is not a function. So, for our sake here, identify the inverse relation and is it a function? So I'm going to draw myself a table. And all they did was they switched your x values and your y values. So what was your y value now becomes x values. And what was your x values now becomes your y values. Do what? Yes. I just flipped the table. What was my x values? See, I just flipped them, right? What was my y values and now my x values? What were my x values and now my y values? So this is our inverse relation. And we have to determine, is it a function or not? So do I have an x value that is used more than one time? No, I've got 9, 7, 5, 3, 1, and negative 1. So since it is not used more than once, it is a function. So yes, it is a function. So basically the x and the y, they just switch spots. Those values just switch spots. So now for example 2, so it tells you how to find the equation of an inverse relation. So we just, f of x y'all know is the same thing as y equals. So they just wrote it as y equals x squared, and then they switched the roles of x and y. So where there was y, we wrote it as x. Where there was x, we wrote a y, and then we solved for y that way. And then they want us to look at the graphs. So write an equation to represent the inverse of f. So I'm going to rewrite it as y is equal to 2x plus 1. And anywhere I have an x value, I'm going to put a y, and anywhere I have a y value, I'm going to put an x. So we've got x is equal to 2y plus 1, and they want us to solve for y. So we subtract 1, x minus 1 is equal to 2y. And then we have to divide by 2, right? So I get x minus 1 divided by 2 is equal to y. Let's see if they wrote an inverse, or how they wrote it. No, they just wrote y equals. Alright, so I put a box around this. And we are going to look at what these graphs of our inverses would look like. So I've got we started off with y is equal to 2x plus 1. That was our original equation. And we say that the graph of y is equal to x minus 1 over 2 is the inverse. Alright, it says the graph of the inverse of x, or of f, is a reflection of the graph y is equal to x squared across the line y is equal to x. So as long as it is a reflection across this line right here that I'm about to draw, let's see, y is, I don't want that though. I wanted it to be, it's supposed to be a dashed line. But anyway, so it's a reflection over this line that is in green. And that it is. It reflects straight over here. You can even tell by these points here. We had a point at 1, 0, and it now became 0, 1. Alright. I'm not going to graph because I don't like this graph on here, so I just wanted you to look it up on see what it looked like on Desmos. Now example 3 talks about finding the inverse of each function by identifying an appropriate restriction of its domain. So we're just gonna look at finding our inverse of this. I'm not going to be worried about restricting our domain. We're going to find our inverse though. I'm just trying to focus on things I know will be on your test. So I've got y is equal to x squared plus 8x plus 16. I know this can factor into y is equal to x plus 4 squared. Now this will be easier for us to find our inverse. So x equals y plus 4 squared. And now we have to solve for y. Start by taking my square root. Plus or minus the square root of x is equal to y plus 4. So my inverse would be, that little -1, that means it's an inverse function. My inverse of this equation would be plus or minus the square root of x minus 4. Alright, we're going to find the inverse of b. X equals y squared minus 9. I just went ahead and switched x and y. Add 9 to both sides. X plus 9 is equal to y squared. And then to get y by itself, we would take the square root. So plus or minus the square root of x plus 9 is equal to the inverse of y. Alright, so you don't have to do anything here again. I just want to show you what it'll look like in Desmos. So we started with y is equal to x squared plus 8x plus 16. And we said the inverse was the square root of x minus 4. Let me see if I can. They got a plus and minus sign. May just have to do 2. So y is equal to negative square root of x, and I gotta go fix this one. That minus 4 is not supposed to be underneath the radical. So this is what the graphs of the inverse. So this was our original in red. The blue and the purple down here is your inverse graph. Just kind of getting you a look at it. Alright, so if we did the same for this problem here, where we had x squared plus 9. Oh, minus 9. That one was much bigger, but that's what the graph of that inverse would look like. It's a reflection over that green line. Alright, moving on to the next problem. Example. Alright, they want us to write an equation, and they want us to find our basically inverse of this equation here. So again, anywhere we have a y, we're going to replace it with x. So we're going to say x equals 2 minus the cube root of y plus 1. We're going to find our inverse equation. And then they want us to make sure it is a function. I'll start by subtracting 2. So x minus 2 is equal to negative cube root of y plus 1. Got to get rid of the negative. So we can do that by multiplying both sides by negative 1. So I've got negative x plus 2 is equal to the cube root of y plus 1. Cube both sides. I get negative x plus 2 cubed is equal to y plus 1. So negative x plus 2 cubed minus 1 is equal to y. They want us to verify that this will be a function before we write our little negative 1 up there with it. So I'm going to come back to it in just a second, but let's verify it real quick. Alright, so we've got y is equal to negative x plus 2 cubed minus 1. Is that a function? Yes, it would be a function that passed our vertical line test. It doesn't look like it necessarily, but these x values are all different. They're just all very, very close, okay? They never are the same exact number. So yes, it is a function. We're going to put our little negative 1 up here. This next part, you are going to need a sheet of paper. To work. So to work A and B, you will need a sheet of paper for 5A and 5B. We don't have enough room in here. It says use composition to determine whether or not they are inverses of one another. So 5A, we got f of x is equal to 1/4 x plus 7, and g of x equals 4x minus 7. I'll give you a second to get that down. Alright, so if we go back and look what our actual book tells us to do here. Well, we already found our equation there. We're on this example here. So it says, what is the inverse of f of x is equal to 2x plus 5, and how can you verify that? First, you have to, nope, that's not the part we need. We want to know, are they inverses of one another? So to be inverses, f of g of x has to equal x, and g of f of x has to equal x. So that's what we did on Friday, where we had f of g of x. Remember, that's f of g of x, like this. I wrote it down on here. And they're telling us to be inverses. F of g of x has to equal x. Oh, thank you. There we go. Sorry about that. So this is where we're bringing in what we did on Friday. So remember, on Friday, guys, we started from the inside and worked our way out. So I'm focusing on g of x now. We just said that g of x equaled 4x minus 7. So now what we have to do is we have to find f of 4x minus 7. So 1 over 4 times 4x minus 7 plus 7. Distribute the 1 over 4. So I'm going to get x minus 7 over 4 plus 7. 7 over 4 plus 7 is 21 over 4. So I get an answer of x plus 21 over 4. Does that equal x? No, I got a little something extra there, right? So since this does not equal x, they are not inverses. Alright, so I'm going to say f and g are not inverses. I'm going to write f of x for 5b. F of x equals the cube root of x minus 1. And g of x equals x cubed plus 1. Alright, remember f of g of x equals f of g of x. Alright, g of x, we just said was x cubed plus 1. So f of x cubed plus 1 equals the cube root of x cubed plus 1 minus 1. If you drop your parentheses, you've got the cube root of x cubed plus 1 minus 1. So they cancel each other out. So I've got the cube root of x cubed. Well, they also cancel each other out. So I'm left with x. And since I am left with x, f and g are inverses. So that's what we want to be left with, just a plain old x. F and G are inverses.